talk about absolute value equations. This is section 1.5. Absolute value is the distance a number is from 0 on the number line. And if you remember, distance is always positive. We can't go a negative distance. Okay, so let's look at some examples. Alright, absolute value is represented by these two straight bars. So the absolute value of -4. If I look, here's -4 on the number line. How many spots from 0 is -4? Well, you should be saying 4. So the absolute value of -4 is 4. Therefore, the absolute value of 6. Now look at 6. Here's 6 on the number line. It is currently 6 spots from 0, which means that the absolute value of 6 is 6. Okay? Absolute value must always be positive, therefore we're basically going to take the positive version of what number is in there. Alright, now we're going to learn how to solve absolute value equations, so when they have an x in them. Alright, absolute value equations usually have two answers. And this is because in order to get rid of the absolute value signs, we have to rewrite the equations, and we're going to rewrite them as two separate linear equations. Okay? Let's take a look at an example. Alright, the absolute value of x minus 3 equals 27. If I'm to rewrite this as two separate linear equations, I'm going to first have exactly what you see there. The x minus 3 equals 27. Now, in order to get rid of those absolute value bars, our second equation must be the negative version. So x minus 3 equals negative 27. So let's think about why we chose 27 to negative 27. If you think about the absolute value definition that we just talked about, what two values have absolute values of 27? Well, negative 27 is 27 from 0, and positive 27 is 27 from 0. Therefore, in order to get rid of those absolute value bars, we account for those two numbers. From here, we would just solve the equation, which we'll see how to do in just a minute. This is just regular algebra 1, and you'll come up with your two answers. First, I want to give you 3 steps that you need in order to solve absolute value equations. Your first one, isolate the absolute value. You'll see an example where you have to do this. Okay. Second, we're going to rewrite the equation as the two separate linear equations. And then the third step is we're going to solve each and get two answers. Okay? Alrighty. If you need to, take a minute and pause that and write it down. Alright, so let's look at our first example. Absolute value of 2x plus 3 equals 5. First off, 15. First off, isolating it. Well, that absolute value is already isolated. It's by itself on the left side. Don't need to do anything more with that. Now we need to rewrite it as our two separate equations. So remember, the first one looks exactly like it is. 2x plus 3 equals 15. The second one, we have to take the negative version. So 2x plus 3 equals negative 15. Alright, that next step says to solve these equations, just like you do in Algebra 1, and you'll get two answers. So I'm going to subtract 3. That'll give me 2x equals 12. And divided by 2, x equals 6. Same thing with the second equation. I'm going to subtract 3 to get 2x equals negative 18, and dividing by 2, x So I now have two answers to my equations, or my absolute value equation. Alright, let's try another one. 2 absolute value x minus 7 equals 16. Alright, first step says to isolate it. As you can see, that absolute value is not alone this time, so we have to isolate it. This is 2 times the absolute value of x minus 7, which means that we must divide by 2. So I now have the absolute value of x minus 7 equals 8. And now I can go ahead to the next step, which is the rewriting. So I have that x minus 7 equals 8, and the x minus 7 equals negative 8. And now I'm just going to solve like I do in Algebra 1, adding 7 to both sides. So x equals 15 is my first answer, and over here, x equals negative 1 is my second answer. Okay, so this is an example where you have to isolate first. Remember that you can pause the videos and rewind at any time. I know I do go fairly quickly, so the videos aren't so long to upload. Alright, now we're going to get into some multi-step absolute value equations. So, I have 3 absolute value 4x minus 1 minus 5 equals 10. Okay, as you notice, there's 2 things that I must get rid of here in order for the absolute value to be alone. That's why it's called a multi-step. So, first thing I gotta get rid of is that 5. So I'm going to add 5. So 3 absolute value 4x minus 1 equals 15. Now I gotta get rid of the 3, so I'm going to divide by 3. Absolute value 4x minus 1 equals 5. I have my absolute value equation. Now I can rewrite it as the 2 separate linear equations. So I have 4x minus 1 equals 5, and 4x minus 1 equals negative 5. I'm going to solve from there. So adding the 1, we get 4x equals 6, dividing by 4, x equals 6/4 or 3 halves. Now I prefer you use fractions in this class. Please don't use decimals. Alright, adding the 1 over here, so 4x equals negative 4, dividing by 4, x equals negative 1. I now have 2 answers. Alright, next one. 2 absolute value of 3x minus 1 plus 5 equals 33. Alright, I want you guys to attempt this one. It's the same kind of thing. Go ahead and pause it at this moment, and then come back, and I'm going to continue to solve it. Okay. If you solve this, you're going to subtract the 5 over and solve it out, and you're going to come up with x equals 5 as one answer, and x equals negative 13/3 as the second answer. Now feel free, if you need to talk to your neighbor at this time to understand how to get these 2 answers, you should do that. Okay? What I will tell you is that when you solve this out and isolate it, you should come up with the absolute value of 3x minus 1 equals 14. If you did not get that, you need to check to make sure you solved and isolated this correctly. Alright, absolute value of 2x plus 3 plus 8 equals 5. Okay, I'm going to do the same thing. I got to isolate. So I'm going to subtract 8. Alright, I'm going to stop here immediately. And why am I going to stop? Take a look. It says absolute value equals negative 3. Can an absolute value ever equal a negative number? Look back at your definition that we gave at the very beginning of this lesson. It says it always must be positive. Therefore, we're going to stop immediately and say no solution on this one. Okay? extraneous solutions is solutions that you'll come out with. So when you come out with two separate x equals, and when you plug them back in, one of them does not work. And we usually will, this will most likely occur when there is x involved on both sides of equations. Okay, I'll give you a minute to copy that. Okay. So let's do two examples of extraneous. So first off, the absolute value of 2x plus 5 equals 3x plus 4. Alright, when I rewrite this, what I have to do is the first one's going to look exactly like it does here. Okay, and then I've got to take the negative version. So on the second one, 2x plus 5 equals, I've got to change both signs, negative 3x minus 4. Okay? I want you guys to go ahead and solve these two equations and come out with the answers real quick. So when I solve these out, I'm going to subtract over the 2x. I get 5 equals x plus 4, subtracting the 4, and I come out with 1 equals x. Okay? Over here, I'm going to add the 3x to both sides so I can keep it positive. So 5x plus 5 equals negative 4. Subtract 5. 5x equals negative 9. Dividing by 5. X equals negative 9/5. Alright, I have two answers. So now I've got to go and check these two answers. Okay? In order to check them, all you need to do is you need to plug them back in up here. So, absolute value of 2 times 1 plus 5 equals 3 times 1 plus 4. So I'm just taking the 1 and plugging back into where my x's occur. 2 times 1 plus 5 is the absolute value of 7. And over here, 3 times 1 plus 4 is 7. Is the absolute value of 7 7? Yes. So that is a solution. Okay? Now, check this one real quick and tell me what you come out with. Alright, what you should have noticed here is when you put in the negative 9/5, you're going to get on one side the absolute value of 1.4, and on the other side you're going to get negative 1.4. Now, can the absolute value of 1.4 equal negative 1.4? Absolutely not. Okay, can't have a negative for an absolute value answer. So my only answer here is x equals 1. This is what's called an extraneous solution. I'm going to put ES right there so you know that's the extraneous solution. This is your actual solution to the problem. Alright, one more problem. value of 2x plus 3 equals 3x minus 2. Alright, isolated, let's go ahead and set up your 2. So 2x plus 3 equals 3x minus 2. And 2x plus 3 equals, I have to change both of my signs here. So this is going to be a negative 3x plus 2. Okay, and I'm going to solve each one separately. So subtracting 2x. So 3 equals x minus 2. Adding the 2. 5 equals x. There's my first answer. Over here, I'm going to do the same thing. I'm going to add 3x. I'm just adding that one because it keeps it positive. 5x plus 3 equals 2. Subtracting the 3. 5x equals negative 1. Dividing by the 5. X equals negative 1/5. There's my two answers. Okay, remember, I had x's on both sides of my equation, so I'm going to automatically assume I need to check for extraneous solutions. When I plug 5 in, that's the absolute value of 2 times 5 plus 3 equals 3 times 5 minus 2. 2 times 5 is 10 plus 3 is absolute value of 13. 3 times 5 minus 2 again is 13. Is the absolute value of 13 13? Yes. So this is a solution. Over here, I'm going to plug it in. Absolute value of 2 times negative 1/5 plus 3 equals 3 times negative 1/5 minus 2. Don't be afraid to use your calculator here with the fractions if you need to. Okay, what you're going to get on one side is the absolute value of 2.6. And on the right side of that equation, you get negative 2.6. Automatically, this should ring bells again. Can an absolute value be negative? Absolutely not. This does not work, so this is my extraneous solution. Alright, you should try your homework for this section. If you have any questions, please feel free to contact me, or you can ask another teacher at the school about extraneous solutions and how to solve absolute value equations. Thank you and have a good day.